In this video, we're going to take a close look at Microsoft Excel and exploring it in depth through a series of tutorials. I hope that you can follow along and download the workbooks from OWL. But before we get started, I recommend that you read over Knowledge Extension 4 in your textbook, as well as the Microsoft Excel tutorial slides. The reason why we're doing this as a tutorial as opposed to a traditional lecture is that I think this is a skill that you learn far better practically through doing. So it is important that you actually follow along with this tutorial rather than just watch it as a passive experience. The first part, we're going to start with a blank workbook and start building it up through there. And as we go through these tutorials, I'll tell you to pause the video in certain parts and think about a certain question I ask you. Do try to pause them at those parts, think about what your answer it is, maybe try it in your own Excel sheet until it works, and then once you think you've got it right, or you get stuck, pause the video and reveal the answer, and we'll continue on with the tutorial. So I know this tutorial is on the long side, around 2 hours. So do take your time as you're going through it. Don't try to cram it all in 2 hours. You'll notice down in the description, I do have links to certain parts in this tutorial that you can jump to. Each part should be denoted, as well as the topics it covers. So maybe after you get to like part 2 or 3, take a break, come back, and then jump right back to where you want to go. Also, if you're using this video for studying purposes or working on your assignment and there's a certain topic you want, do remember that you can look at the transcript and search and jump to the part that you want, or you can once again look down in the video description and jump right to where you want to go in the video. In part 1 of this tutorial, we're going to be giving a brief overview of Excel's GUI, this graphical user interface, as well as how we do some basic visual formatting on cells. So if you haven't installed Excel yet, make sure you watch my video on installing the software required for CS1032. Once you have Excel installed, it should either show up on your desktop. Here you can see one icon that says Excel, or if it's not on your desktop, you can probably find it by searching for Excel in the Windows Start menu. So when you first start Excel, you'll see something that looks like this. There'll be a few options here. So in most cases, you want to click on Blank Workbook, and this will give us a new Excel sheet. If you're interested in learning more about Excel, some of these options shown to the right here will give you tutorials and overviews of some of the features of Excel. So these might be good options when you want to learn more about Excel, but if you want to create a new Excel document, click on Blank Workbook. So you'll see down here, we have a little zoom indicator. So right now it says 100%, so I'm going to increase this to 150%, just so we can have a better look at everything on the video. So when you first start Excel, you'll notice that there's some numbers down the side and some letters around the top. So these numbers down the side are row numbers, and these letters at the top are column numbers. An Excel sheet is made up of a table of cells. And our cells are individual little spots where we can put data, and they are addressed by their row number and their column letter. So this cell right here, we put Hello World, would be considered to be cell, let's see, E5. And that's because it's in column, and we always list the column letter first, and it's in row 5. And we always list the row number second. And we can see that up here. It gives you the cell address. So for now, it'll just keep that in mind, and we'll start using that when we get into part 2 of the tutorial. But important thing is that each individual cell in a worksheet has its own address given by the column letter and the row number. So next thing you'll notice are all these things at the top. It says File, Home, Insert, Page Layout, Formulas. These are different tabs. What the tabs do is they change the features that are displayed in the ribbon. So the ribbon is this big area up here, and it gives us a bunch of options that we can use. So right now we are on the Home tab, and the Home tab mostly displays formatting options to change how our cells look visually. We also have tabs for inserting new items into the sheet. We've got ones that affect this page layout. We have ones that are for inputting data into your sheet. We've got review features like spell checking. And we have things that change how we view or visualize the sheet, like zoom level, if we're displaying grid lines or not. And we'll go into some of these in a bit, but for now we're going to focus on some cells. So to start with, we are going to be just entering some data. So one common thing we want to use Excel sheets for is storing data in a tabular format. So what we're going to do in this example is we're going to store basically a budget. So on the left-hand side, down in column C, we're going to have each month. And on the right, along row 3, we're going to have different budgetary items for our home expenses. So maybe like rent, car payments, things like that. So we can start by entering January. And one interesting feature of Excel is that we have this drop-down menu. And Excel is smart enough to auto-fill in what we want. So when we pull it down, you can see in that little box there, it's giving suggestions. So that's what it's going to fill in. In this case, it's smart enough to know that after January comes February, after February comes March, after March comes April, and basically fill that in for us. So we didn't have to type all those out individually. You can do the same thing with numbers, but with numbers, you want to give it at least enough data so it can detect a pattern. So in this case, 1, 2, so the next thing in the pattern would be 3, 4, and so on. So if we were to pull that down, we'd get the numbers 1, 2, 3, 4, all the way down like that. So that's filling it downwards. So at the top, we're going to put in our different budget items. So we might start with rent, and I'm using tab to move to the next cell. If we type in rent and hit enter, we go down a cell. So tab goes to the right, enter goes down. If we wanted to go to the left, we could type shift tab. So another expense might be car payment, also have gas, have food. So you'll notice when we're doing items like this, Excel isn't going to be able to detect a pattern. So if we were to try to pull food down, for example, it's just going to go food, 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 because it doesn't know what the pattern there would be. So the autofill is only going to work when there's a clear pattern for Excel to detect. We can also do school. So now I'm just going to type in some data. So for rent, we'll say that maybe $8.50 a month. So if we don't give it extra examples like 850, 851, and so on, when we pull it down to fill, it's just going to give us the same number because it's assuming we just want the same thing pasted in. So for the car payment, we can say it's $450. We could do something similar with copy and paste. So in this case, I'm going to hit Control C to copy. I'm going to select the area I want it to copy in and hit Control V. So that's just another way of doing the same thing. So for gas, we could say we're going to do 50 a month. And another thing we could do is there's this little green square in the bottom right of the cell. If we double click on that, Excel is going to try to autofill that down until there's no more rows to match. So basically it's smart enough to detect if there's more data on the left-hand side, and it's going to keep pasting that down until it sees that we're ending our data. So that can save you a few seconds. You don't have to manually pull it down with the mouse. Instead, you can double click and it'll pull down the pattern, or it'll pull down the value it can detect. We had, for example, 1, 2, and we highlighted both and then double clicked the bottom right. It would detect the pattern and fill it downwards. So for gas, we'll say that maybe in January when we're heading to school, we're going to spend a bit more. Maybe we're going to go on a road trip in the summer, so we're going to spend more on gas there. And maybe we'll spend more on gas during the holidays when we're visiting relatives. So food, we can copy in the same number each month. We'll do the double click method to fill downwards. And for school, we'll have some tuition January. We'll have some tuition in September. And we'll have a small payment for our summer course. And we can fill the rest in with zeros. So the point right now is just showing you how we can actually get some data in Excel. So while you're entering data, you might figure out that maybe I wanted to add another budget item, but I wanted it to be in between gas and food. So to insert a row, we don't have to actually move everything over or retype everything. We can just highlight row G, right click, and click insert. Then we could add a new row for something like video games. So same thing with rows. If we wanted to add an extra row, we could click on the row and hit insert, and I'll insert above that row that we highlighted. Since I didn't want to do that, I'm going to hit Control Z to undo. So one thing you'll notice is the end of September here is a bit cut off. So are the R's in November and December, as well as the rest of the word video games. So the problem here is that our column widths aren't big enough to show the whole thing. So to adjust the column width, you simply drag on the line and you can change the width. So you can pull it further, pull it shorter. One trick is if you double click on this line, Excel will auto size it for you. So it'll just fit the text. So we can double click here and it'll just fit the text here. It also works in the other way to make cells smaller, like this. And the same thing is true of rows. So we can make rows bigger, or we could double click to make them smaller. If we wanted to be really picky about it and set an exact width, we could right click on the row, select column width, and type in an exact number, like 15. And that would change the width of the row. So something else we'll want to do is maybe put a nice header at the top of our document, or a title to the document. So we can say my costs. And maybe we also want to say the date we made this. So one thing you'll notice as we're inputting data, all the text is being left justified and all these numbers are being right justified. The reason for this is Excel is noticing that this is text, and by default text is always left justified. It's also noticing that these are numbers, so it's formatting them as a number and right justifying them. So if we want to input a date, I could say May 4th, 2020, and you'll notice that it changed from the text we typed in to this differently formatted date. Reason for this is Excel detected that that was a date, and it's actually going to format it in the system's local date format. So that could be slightly different on your own computer. It's whatever your default date format is on your setting will be what it changes to right away. So we might not want to use that date format. We might want to have a different date format we had in mind. So the way we get into that is we go right click, we go format cells, and this gives us a bunch of options to basically tell Excel how we're going to format this data. So there's two different types of formatting in Excel. There's text formatting, that's more from what you might be familiar with Word or programs like that, where you're going to make things like bold, underline, different font colors. And then there's actual data or number formatting. So what we've got into here are the number formats. So this is a date, so we want to format it as a date. It gives us some different options down here. So for data, Excel can actually interpret them differently and display them differently based on its interpretation. So in this case, we might want to be a little more fancy and say the whole month name and then the year. So we can select that option and we can see that it changes. But even though it's displaying it differently, Excel still knows that it's the same date, and that will become important later. So for the same thing, for all of these numbers over here, these are all dollar amounts, but they don't have like a dollar sign or anything like that. So we want Excel to still recognize these as numbers and not text. So we're going to have to give it a number format. So we could do the same way I showed by right-clicking, going into Format Cells. There's also a shortcut for that. We could hit Control 1, and that brings up the same box. Or in the Home menu, you can see up here there is a number formatting section. So for this, we could select and drop down to Currency. And it formats all of these cells as a currency. We have two options here. It looks like an arrow and some decimal points. And these basically affect how many decimal points are shown. You'll also notice that it changed the width. So if we wanted that to go back, we just right click there. Or sorry, we just click on the line there to auto fit those again. And one thing you might notice if you're working in Excel, you might see these little hash signs. So what these hash signs mean, it doesn't mean there's an error or anything like that. It means that the width of the column or the height of the row is too small to actually display all the data. So that just means you have to make it a bit wider so you can see everything there. So now that we have our data formatted, we might want to apply some text formatting, some visual formatting. And this works very familiar, or this should be very familiar to you if you've ever used a program like Word or a word processor. It has the same sort of options, and you can see them here already, the font formatting options in your Home tab. So we might want to make all these months bold. So I hit Control B, that's one way we can make them bold. Or we can actually go up and click bold. We might want to, for example, make this bold as well. Maybe make these titles red. So we're changing the font color here. So we could actually drop down and select different font colors, or I could just select red. And so for my costs, we want this to be a title for the document that's actually centered across the whole document. If we just click center, it's only going to center within the cell. So these alignments are right justifying, center justifying, etc. within the cell. It's not across the whole document. So if we want to do that, what we can do is something called merge cells. And that's this option right here in the home ribbon. So what that did is it basically made all these cells one big cell, and then it centered it within that cell. We could still apply our left justify, right justify alignments, but now they're across one big cell instead of many little cells. So another thing we can do is we can apply backgrounds to the cells, background colors. So maybe we want to change all this to a nice gray color, do a light gray, change this to a darker gray. And one thing you'll notice when you're doing some of the MyLab homework is that it might ask for a specific color to color a background of a cell. So when you're in this little option here, the theme colors, if you hover over a color, it should pop up a little box that will give you a description of that color. So sometimes in those MyLab assignments, it will say color it blue-gray, text to lighter 80. So the way you find those is you just look in this menu for one that has a matching description. So another thing we might want to do is once we put that cell background color in, we sort of lost those grid lines. So we can manually add those back with borders. And this gives us a whole bunch of different border types. In this case, we might want all borders. We're just going to fill them all in like that. Let's bring back those borders. We could also change the alignment on the titles to make them all centered. So even though that text is by default left justified, we can change that using the formatting options. And we can make the font bigger. We could change the font. Give it a nice color. So basically, most of the formatting options you're familiar with programs like Word are also available in Excel for the cells. The important thing here is that text formatting, like the colors and stuff, don't affect the actual data that's in the cells, while data number formatting shows how that data is being represented. So number format might like add $signs, decimal places, while the text formatting would add like colors, bold, underline, things like that. We can also do bold, underline, italics. So we can get into a little more advanced options when we go into, for example, the Insert tab. And this will allow us to actually add in things like shapes. We could insert even things like pictures. Let's see if I can find a picture for us to use. So an important thing to note about the shapes and pictures that you insert for the insert menu is they're not bound to a single cell. So they're not actually contained in a cell like all our data. They're just sort of visual things that you can add to make your spreadsheet look a bit better. Another thing we can do in page layout, and page layout ribbon mostly affects how this document's actually going to be printed if we printed it. There are some things that will change the visual appearance as we're viewing it in Excel, but for the most part, these are all things that will change how it's actually printed. So one thing we can do is we can change the margins, we can change the orientation. So if this is going to be printed as a portrait piece of paper or a landscape, we can change, another important one over here is the scale. So right now, it's going to just sort of automatically decide where to cut up this document if we were to print it. So it might like cut down here, which wouldn't be ideal, or it could cut down here so they won't be on the same page. So we can give Excel some hints about how to actually format this for when we print it. So first what we can do is take a look at what it will look like in a print preview. So right now, if we were to print this out, we'd sort of get part of it on one page and part of it on another page. So that might not be very desirable. So what we can do is we go to width and we say one page. So we're saying we'll fit everything widthwise on a single page. If we do the same thing for height, if we did one page for width and height, everything would have to be squished on a single page. But it's important to note that if you start moving things further and further to the right, everything is going to get shrunk down more and more when you print it. Page Layout tab also has things like grid lines. We can disable our grid lines. So normally when you print, the grid lines won't be shown. So mostly grid lines is just for a visual effect within Excel. One thing you might notice is that I went to sort of a print preview mode, and we can control that in View. So if you want to look at your page layout view, you go View, Page Layout, and that'll show you how it's going to look when it's printed. If If you want to go back to a normal view, you hit View and you click Normal. This back. So another thing we might want to do is apply headers and footers, similar to like we would in Word for a Word document that we're printing. We might want to put a title along the top. This is something the MyLab homework might ask you to do. So we do that through the Insert menu. We go Insert, and then we click on Headers and Footers right here. And this will bring us to that page layout view, and it will show us a new header area where we could type text in. So we could, for example, I could say made by Daniel Servos. And with the header and the footer, we always have like three options. There's the left side, the center side, and the right-hand side. So we could add just plain text, like titles, whatever kind of label we want to add, but it also gives us a few options up here. These are sort of automatically generated text, like page number, the current date, and things like that. So one thing we could do, we could add the sheet name of the current sheet. We could add in the current date. So whenever this is printed, it would have the current date on the left, the sheet name, which is right now just sheet 1 by default, and it'll say made by Daniel on the right. To get to the footer, we just scroll down, and we can add text in the footer. So for example, we could add the file name, so that would be the actual file name. So right now this hasn't been saved yet, so it just says book 1. We could add other things like the current time, and we could add even like the page number. So one thing you'll notice is when we go back to a normal view, scroll up, you can't see the header or footer. So the header and footer aren't actually in cells. They're in sort of a special area above and below the document. That's only going to be important when we print that document. So when we print that document, we'll get those titles, the file name, and the page numbers actually printed out. But when we're actually just looking around Excel, working on the document, we're not going to see it. So what I did right there is I'm zooming in and out, and you can do that by hitting Control and using your middle mouse button to scroll up or down. So now that we made our Excel document, we're going to want to save it. And you really should save right away and save frequently. So we can do that by going File, Save As. We can hit Browse. If we want to save it on this PC, we can hit this PC or we can hit Browse. In this case, I'm just going to drop it on the desktop, and we'll name it Example 1. So by default, it should be saving it as an XLSX file. So that's what we want to save our Excel sheets as. If you look in here, it does have a whole bunch of different options. On older versions of Excel, or if you have it set to use a compatible file type, you'll see something like this. It'll say Excel 97 to 2003 Workbook XLS. We don't want to save it as XLS when we're doing our assignments and the MyLab homework. We always want to make sure that we're saving it as Excel Workbook XLSX. So to save from here, you just hit Save. And now whenever you want to save again, to update the file, you can either click the Save icon up here, or you can just hit Control-S to save the workbook. So the other thing I mentioned was the sheet name. And you can see down here, we have a little thing that says Sheet 1. So a workbook can store multiple sheets, so multiple tables of cells. So first of all, we can give this a name. Just double-click it. We could call it My Costs. And we could add in another sheet. Call it like My Grades. We could start entering more data in here. Like courses 1032, 2034, 2211, and then like some grade. So important thing to note is you can see that this sheet has its own addressing. So D6 in the My Grade sheet is not going to be the same as D6 in the My Cost sheet. So you could have any number of these sheets in your workbook, but each one of them is going to have its own address system for these cells. And that about brings us to part 2. And in that part, we are going to start talking about how these cell addresses work and how we can reference cells. In part 2 of this tutorial, we're going to be taking a closer look at cell references and some basic mathematical formulas. So here I just have an Excel sheet up, and I'm going to type in basically the cell name of a few cells. So this is cell C4. If you recall from before, in the last part 1 of the tutorial, we said that a cell is named or addressed by its column number, in this case C, and its row number, in this case 4, and shown up here as C4. So we could look across, we see that that's in row 4, it's column C, so we call this cell C4. In this case, I've just typed in the name C4. This could still hold whatever we wanted in that, just like we saw in the other part. It could be like hello world. But for now, we're just going to give a few cells the same values as their address. D4, E4, F4. So we're down 1, so now this is C5. It's going to be D5, E5, and F5. So if you ever have any doubt what your cell address is, you can always see it up in the right-hand corner here. So we're down another row. So now we're going to be at C6, E6, and we're going to be at E6, and we're going to be at F6. So we saw so far that we could put in numbers, we could put in text, could put even dates. But another thing we can put in Excel cells, other than actual data, are references to other cells and formulas. So a formula in Excel always starts with an equal sign. So you can see here I typed in equals. And that can be followed by either a mathematical expression. For example, we could say 1 plus 1, or we could do 2 times 3, multiplication. You can even do powers, so 2 to the power of 2. And we can even do things with strings, like we could say hello and world, and that basically concatenates 2 strings together. We can even do logical operations, like is 3 greater than 4? So it's false, because it's not. Or we could say is 4 greater than 3? That's going to give us true, because it is. But another important thing we can do in these formulas is reference other cells. So I could say equals cell C4. So this is saying we're going to make this cell equal to whatever's in cell C4. And you can see once we type in a cell reference, Excel highlights the cell in that color. So since we typed in C4, it's showing C4 highlighted in blue. And when I hit enter, it says C4 because it's referencing that cell. So it's important to note that this is a reference. So it means Excel is actually looking up the value of the cell each time. It's not copying and pasting the value in. So for example, if we change this to cat, this cell will also change to cat. And if we were to, for example, now reference down here, E12, this would also be cat because it's referencing this cell, which is then referencing this cell. So if we went back here and changed it to like dog, they all update. So far that's pretty straightforward. I'll change this guy back to C4. But what's really special about Excel is what happens when we start pasting and copying these cell references. So we're going to start another formula, and we're going to reference another cell. This time we're going to reference cell D5. So I could type in D5, or we can also just click on D5, and Excel types it in for us. That's a little bit easier. Now what's special is if we were to copy and paste that cell, the one with the formula equals D5, into cell F12, you can see that it now says E6. And if we look up here in the formula bar, this tells us what the actual formula is in that cell. It says the original cell is equal D5, but when we pasted it, the formula changed to equal E6. The reason for this is called a relative cell reference. So that means when we copy and paste it, it's going to update based on how far away it was copied and pasted from that original cell. So in this case, we pasted 1 over and 1 down. So if we were to look at where the original D5 is, if we go 1 over and 1 down, we get to E6. So the address was updated to E6. So for example, if we change this reference to be cell C4, and we copied and pasted it down here, we get cell C6. The reason why is we went down 2 cells, so the reference is going to be updated 2 cells. And if we look at the formula, it now says C6, even though the original one was C4. So basically, whenever we have a cell reference in a formula and we copy and paste that, it's going to update that cell reference. What's also interesting is when we pull it, like we saw in our other example where we're doing with just data, if we pull references, they also will paste in, but they update each time. So in this case, we pulled to the right, so that means we went to the right once. So the cell was updated from C4 to D4. We pulled to the right again, so it's updated to E4, and we pulled to the right again, and it was updated to F4. If we, for example, were to pull this down now, some interesting things happened. So we pulled down a number of formulas. They all went down by 1 cell. So over here, they're going to be updated to the ones below them. So in this case, C4 was updated to C5, D4 was updated to D5, E4 was updated to E5, and F4 was updated to F5. The same thing happened when we went down again, but then something interesting happened right here. So what happened here is we pulled it down again, and now it's referencing cell E7, or C7 rather. But cell C7 doesn't have anything in it. So by default in Excel, if you reference an empty cell, either just like this, saying equal E7, or we do it in a formula, we'll see some more of those later, but we try to do it in a math formula, Excel will always replace an empty cell with a 0 when it's done in some sort of mathematical operation like addition, multiplication, things like that. So in some cases, we don't want this to happen. We don't want the Excels to change when we paste them. So for example, maybe we had an important cell up here. Let's say we had a tax rate. We had 15%. We always wanted to reference this 15%. If we did something like equals B1, and then we pasted this somewhere else, we're now getting D4. So why are we getting D4? So one thing you should try is pausing the video right now and seeing if you can figure out why we got D4 in this case. So what happened is we look at the references. We see equals D4. The original was equals B1. So we pasted down 1, 2, and then down 1. So if we do the same thing, we go 1, 2, and then down 1, we can see that we're at cell D4. So that reference here, equals B1, was updated to equals D4 because it went the same amount to the right and the same amount down. But we might not want that to happen. Maybe we always want to reference that tax rate. So there is something we can do, and that's called absolute referencing. So the way we express that is we put $signs in front of both the column number and the row number in this case. And that basically tells Excel, lock in that column number, lock in that row number. So when we copy and paste it, neither of those will change. So you can see we have the absolute referencing. So when we go Control-C and copy it to different places all over the sheet, it's always going to be that equals B1. And this is still a reference to the cell. If we were to change this to 12, I should say 12%. All of those update because they're not copying and pasting data, they're copying and pasting an absolute reference. Let's clean those up. So you saw that we put a $ in front of both the B and the 1. So that locks in both the column and the row. If we wanted to, for example, we could just lock in the column. So in this case, I'm putting the $ just in front of the C. We're just locking in that column. We're just making the column the absolute part. Then when we paste it down, it's going to act as normal. And we can see that only the row number is changing. That's what we'd expect. But when we paste it to the right, we're still getting those C4s. And we paste those down, only the row is updating. So you can see because that $ in front of the C, whenever we paste it, it's always going to be a reference to column C. But it will still update the row number. So we could even copy it and put it way over here. It's still going to be C4 because the column will never change. However, if we copied it, put it way down here, we're going to get some 0 number because it's now moving the row number down. So because the $ is not in front of the row number, that's not locked. It can change freely, but the column is locked. And we could do the same thing with the row numbers. So instead of locking the column, we're going to lock the row. So pause the video right now, and I'm going to drag this down and try to predict what's going to happen. So what will the cells be when I drag it down and when I drag it to the right, now that the row is locked? So pause the video and try to figure out what that will be. Okay, so we're going to give it a try. So we're going to pull it down 2, and we're going to pull it to the right by 3. And hopefully that's what you predicted happened. In this case, we started with C4, with the row being locked in. So when we dragged it down, the row didn't change. And since we're in the same column, there is no change. When we moved over a column, into column F here, we have to update by 1 column. So it went from C to a D. Though even though we're in different rows here, since the row is locked, it's still in row 4. So we're still referencing the same row. So it's the exact same idea as we saw before with the locked in column, except now we have a locked in row. So another thing Excel allows us to do is something called named cells. So when we're on a cell, for example C4 here, we can click up in this box. I'll highlight it just to make it a little more clear. This box here, where it was showing what the actual cell address is. And we can edit that to a different name. So we can't put in another cell address, but we could put in something like my cell and give it a special name. So now, if we're way over here, we can say my cell, and it will look up that name of the cell. And one special thing about named cell references is that they're not going to update when we pull them. So now if we pull it all over here, pull it down there, copy and paste it around, it's always going to be equal to C4 because we're saying equals to that named cell. So one thing that I should also cover is there are some ways that we can move around Excel faster. So we can use the arrow keys just to move one cell at a time. We already saw how we could hit Tab to move over cells or Shift Tab to move to the right. But there are a few other ways we can move around and select things. Okay, so right now we are on cell C4. If we wanted to jump to the last cell that we've entered in the row, we can hit Control right arrow. And this will jump us along all the way to the next cell. So if there's a space, it would break it. So we could say text. And now if we hit it, Control right, it just jumps until it detects a blank cell. And that can be in any direction. So we could go Control down, we jump down, Control left, we jump to the left, and up to the up. So it's quite useful when we're trying to move around in a table of data. We can also use this with Shift to select multiple cells. So if we just hit Shift and an arrow, it's going to select 2 cells. We'd move over We can extend the ranges by just hitting Shift and then or direction. So we basically hit Shift and then an arrow key, and it extends that selection either up or down. But using Control Shift and then an arrow key, we can keep selecting all the way to the end of text. So we hit Control Shift right, we select that whole area. And then if we hit Control Shift down, we select all the way down. So we basically just got that whole table. And there are quite a few useful Excel shortcuts. If you're interested in that, I will post some links in the resources, but they can really help your productivity. You're not going to be tested on these shortcuts at all, but they can help you get those assignments done faster and deal with like a large data in your sheet faster. And you'll probably see me using a few. If I do, hopefully they'll be recorded by this program down here and show them on the screen. It doesn't have all of them, but it has some of the most useful ones. So if we recall from before, I said that we can have multiple sheets in our workbook, and that the sheets have the sheets have their own addresses for each sheet. So for example, even though cell C4 has the text C4 in the sheet, in our other sheet, we could type something else in here, like hello. And when we type in equals C4, we're going to get the value of C4 on the current sheet. We're not going to get the value of C4 on our first cell sheet. However, there is a way to reference cells between sheets, and this is something you'll have to do in your assignment. So instead of just typing equals C4, what we can do is we say equals the name of the sheet. In this case, our first sheet was called cells, an exclamation mark, and then the cell reference. So in this case, C4. And we're getting the value of C4 because it's referencing the cell over here. If we were to update that to something else and look back on the sheet, it will update the value over here because we're looking at the other sheet and then we are pulling the data from it. So one easier way to do that is we type equals. So we're currently entering a formula, and then we go to the cell sheet and we just select the cell we want. You can see that currently Excel's typing in a formula. This is equal cells, an exclamation mark, so type that in for us. And then when we pick a cell, it fills in the rest, and we can hit enter, and we jump back to our other sheet, and it's entered the formula for us. So we can either enter it by hand like that, or we can type equals and then pick the cell that we want, just like with other cells. And we can use absolute references with this. So if we were to pull this to the right or to the left, we're getting the cell updated. So it's updating from F6 to E6 to D6, but always on the cell sheet. So that's pulling these values in. If we wanted to make that an absolute reference, we could do the same thing with a $sign here and a $sign here. And now when we pulled it to the right, it would always be that same cell. So it is a pain to sort of click in there and enter the $signs each time, like if you already typed in C4, and then go back in and try to like pick the right spot and put a $sign. So one shortcut you can use is F4. And F4 will basically cycle through the different absolute references. So the first time you hit it, it's going to put an absolute reference on both the column and the row. The second time, it's just going to put it on the row. Third time, it's going to put it on the column. And the fourth, it's going to give you back to the no relative reference. That's just another way to make your work a little bit faster. So now we're going to try to actually make some use of the cell referencing by making a multiplication table. So multiplication table basically has a header with the numbers 1 to 9 on the top, and a column with the numbers 1 to 9 on the side, and then each cell inside a multiplication table basically shows what the value would be of multiplying those two numbers together. So we'll start up here in B3 with a 1 and an A4 with a 1, and now we want the numbers 1 to 9. So one way we could do that is give it a second example, highlight them, and then drag to where it would be 9. A different way we could do that is with a formula. So we could say equals, actually we'll start back here. So we could say this formula is going to equal the value of A1. But instead of just saying A1, which would just give us another one, we could actually use math. So we can use sort of like mathematical equations with these cell references. So if you've taken basic math course, this would just be like an x variable, except instead of x, it's saying whatever the value is in cell A4. So we want the value of A4 plus 1, so we add plus 1. So now this cell is equal to A4 plus 1, which is 2, which is pretty basic. And we probably wouldn't want to keep typing in like, now we want to type in A5 plus 1. That would be a pain. It's not any easier than actually just typing out the numbers. But what we can do is we can drag the formula down. And what's happening is Excel is just doing the same formula, but it's updating those references, just like we saw before. So the cell reference is changing each time. So the first time it was equals A5, we dragged it down and it became A6, A7, and so on. So the important thing to note, the only thing that's changing are the cell references. It's not going to change any constants we put in. In this case, the constant was +1. So it only changes cell references when we drag them. And this allowed us to get those numbers, because each one's referring to the one above it. So if we were to change this number up here to like a 7, it would change all the ones that follow it. So it's going to give us the same values in the end as we did up here, but it's going to have a few different behaviors. Because now if we were to change a value up here, they all change. But if we did the same thing up here, because these are hard-coded values, they're not formulas, they're not going to change. So it is important to know which kind you're trying to use. Do you want hard-coded data that's not relying on anything else? Or do you want relative formulas that are going to update on the value of some other cell? So now to actually get to making our multiplication table, let's start by making our row and our column headers bold, just to differentiate them. And inside this table, we're going to want each cell to equal to the value of the header times the value of the column header. So we can get started actually making our multiplication table now. And we're going to do that based on a formula that multiplies the value in the header with the value in the column header. So in this case, we want B3, which is going to be the value up here in the header. And we're going to want to multiply that by the value of A4. We get the value 1. Now we could do the next cell, which is C3 times A4. Well, this would be a pain. Just go for the whole table and type in each one. So you might be tempted to drag again. So we got our formula up here. We got B3 times A4. So surely we can just drag it, that, and drag it down. Well, it seems like something went wrong. So at this point, I want you to try to figure out what went wrong. Let's take a look at that. So this was the first cell, and we dragged it to the right and the bottom. Pause the video, try to figure out what went wrong and how do we fix it. If we take a look at what happened, we can see the reference here. It starts off okay. We're referencing B3 and A4. But when we go to the next cell, it's referencing C3 and B4. So that's a problem, because we want this to be based on the column. We don't want it to be based on the next row or the next one beside it. And this problem grows as we get over here, because we're no longer basing it on 9 times 9. Instead of we're basing it on the one above it and the one to the side. So we're going to have to use some absolute references to fix this. And this one's a bit tricky, because we can't just make them both all absolute references, because if we pulled it now to the right and down, we're always going to get the same result, because it's always referencing the same cell. So we have to be a bit smarter about it. So we know in this row, we're always going to be wanting to reference cell A4. So we're in row 4, we always want 4. We know in this column, we're always going to be wanting to reference cell B3. Because we're in column B, and we always want to reference row 3. And we know no matter where we are in this table, this header is always on row 3. And no matter where we are on this table, this header is always in column A. So we're going to lock in row 3 in this equation, or in this reference. We're going to lock in column A in this one. So now when we pull this to the right, and we pull it down, we're going to get the correct result. It's only allowing the row to change in this direction, and it's only allowing the column to change in this direction. So for example, when we get down here, we allowed in the cell, this second reference for the column header, we're allowing the row to change. So now it's all the way up to row 12, but it's always locked into A. So the column can never change from A in this reference. When this blue reference over here to the other cell, we're saying that the row always has to be 3 because the numbers are always in this row for the header, but the column can change based on where we pull it. So for this cell, if we take a look, it's over this much and down that much. So what happened is in the original cell, the values of the column were B3 for the first reference, and 3 is locked. So even though we pulled it over and down, it's basically ignoring the down part because 3 is locked. So it's only taking into account the change in columns. So we change to column J. So it's sort of the opposite way around for the other cell in our formula. In this case, the column's locked, A, and the row is free. So when we go down here and we look at the red reference, the second cell, we can see even though we changed a bunch of columns going this way, the column's still locked, so it's still A. And when we went down number of rows, that was free to change because it wasn't locked in. So it is important to understand the absolute and relative cell references because they can make a big difference. If we used any other kind of references in this table, we'd get the wrong results. So one other thing that can make it a little bit useful to see what's going on in your worksheet is a shortcut called Control tilde. So tilde is kind of hard to explain. It's the little character that's to the left of the 1 number on your keyboard. When you hit Control that, Excel switches from showing the results of formulas. So all of these have formulas in the cell, and it's showing you the result. So that's the normal operation. When you hit Control tilde, it switches to showing you the formulas. And that can be helpful when you're trying to debug what's going on in your spreadsheet, because now we can see what's actually in these cells, rather than what the result is. And again, to switch between that, it's just Control the tilde key, which is to the left of the number 1 on your keyboard. In part 3 of this tutorial, we're going to be taking a look at some basic Excel functions and how we can use those in our formulas. So on the screen now is our budget from part 1. Let's remove these. And right now it's not very useful. It's just some data in Excel. We haven't really processed it at all. So what we can do is we can add a new column called total and a new column down here called total. And you notice that it's going to automatically apply some formatting that matches what we've already done in that row and column. That's okay. We could always clean it up later, but for now I'll leave it as it is. So in this row down here, we want to have totals for each column. So we want to say like how much we're spending on rent in a year, how much we're spending on our car. And in this column here, we want to have totals for the rows. So we want to say how much we're spending in January, how much we're spending in February, and so on. So we could enter this manually with an Excel formula. We type in D4 plus E4 plus F4 plus G4 plus H4 plus I4. And that would work fine, and we could pull it down. But it's a bit of a pain, especially when we want to do the one down here, where we'd have to type in D4, D5, D6, D7, all the way down. So what we can do is we can take advantage of Excel functions. So these are built-in functions made by Microsoft that basically already encode how we can do some mathematical operations. So there's ones for things like average, summations, all kinds of statistical and financial ones. You'll see a bigger list in those Excel tutorial slides that I posted and in the resources on OWL. For our purposes now, though, what we really want is to do a sum function. So the function is called sum, S-U-M, and it takes something called a range. So we've seen before how we can reference a single cell. For example, we could say D4 or E4, but we can also reference a range of cells. So if we wanted to say all the cells we're taking a sum of, we don't have to list each one individually. Instead, we can just list the first cell in the range and the last cell in the range. So we could type this out manually, D4, that's the first cell in the range, a colon, and the last cell in the range. So that would be I4. So we're going to say, take the sum of the cells D4 to I4. We always end our functions with a bracket, and we hit enter. And that gives us the sum. So we can also see the formula up here. And one very important thing is when we're typing in a function name, if we say equals and we start typing, it gives us a list of the functions built into Excel. In this case, sum. And then it tells us basically the parameters these functions take. So this case, it says it takes a number. If you see values that have the square brackets around it, or parameters that have square brackets, it means those are optional. So what this is saying, we could also use the Excel function by giving individual, or the sum function by giving individual cells like this, or adding a range. So that can be a useful feature if you don't know how to use a function. It does give you some tips, very mild tips on what parameters it's expecting. So instead of typing out the range manually, and we just saw me do it a little bit, we could also use our selection tool here to select a range. And the way we select a range is we click on the first cell, and we just hold down our mouse button and drag it over to the last cell. And that basically types in the range for us. So that can be a bit easier. Rather than having to type it out manually each time, we can just sort of select it in our workbook. And ranges will update just like normal cell references. So each cell in the range updates. So when we pull it down, the cells update. So we're always taking the sum of the columns to the left because all of the row numbers are updating. The column numbers don't update because we're not dragging to the right. If we were to drag this to the right, you could see that it updated the range and it moved it off a bit. This doesn't give an error because remember, Excel treats those blanks as 0. Instead, it just gives an incorrect result. So while working on your assignments and things like that, you have to be very careful because many times you can get Excel to spit out a number. Doesn't mean the number is correct. Just because you don't get an error doesn't mean it's right. So you have to check over your work and make sure the numbers make sense. So if this was an assignment, you might want to actually add up these numbers yourself to make sure you're actually getting the correct result, at least when you're getting started with Excel. So we can do the same thing on the bottom using the sum function. And we can take the sum of all of these numbers in this range. And then when we drag it to the right, it's going to update. In this case, it's only updating the column values. So you can see that we got these two hash signs. So this is a good question. So what went wrong? So if you watched the first part, you should have an idea. So maybe pause this video and try to take a guess of what went wrong here and how we could fix it. So in this case, nothing actually went too wrong. This isn't an error, it's just telling us that we haven't given enough width in this column to display the whole value. So to fix this, all we do is we just pull to the right, and we can make it bigger so we can display the whole number. So something like that happens where you're getting all hash signs, it just means you need to give a little more space for it to display the whole value. So in this square down here, maybe we want to know the whole value of all these numbers, the total value of the budget. So we could take the sum of this, or what we could do is we could use a two-dimensional range. So instead of just selecting a single row or a single column, we can select this whole table. This says it's still being referenced the same way, the starting cell D4, the ending cell I5, or I15 rather. And that's going to take the sum of all of these values inside that two-dimensional range. So ranges can also be two-dimensional. And just like with normal cell references, we can also use absolute cell references in them. So now if we were to paste this over here, we're going to get an error because it's going to be invalid block. So for example, we also pasted it over here. We can see that it's basically moving this big two-dimensional range over more and more. So the reason why we got an error here is because it's being self-referential. So if you get a loop, so in this case it would have been referencing the same place as taking the sum of, you're going to get an error like a ref error. So what we can do is if we want, we can actually add those absolute references back on. So we need to do it on both the columns and the rows of all of them. Since that's an absolute reference, now we can paste it wherever we want. It's always going to reference that same two-dimensional range. So it's always referencing here, it's always referencing there. So the same rules apply to ranges as they do with cells when we're talking about absolute and relative referencing. So now we're going to take a look at a more realistic example. So in this sheet, I have a bunch of student names and grades, and this is supposed to simulate basically the grades being entered for a course. In this case, we can pretend it's 1032, but all these are just made up names and made up assignments. So on the top here, we have a bunch of assignment names, quiz names, and a final grade. Here we have a list of students. Here we have what section they're in. So there's 3 different sections. There's section 1, section 3, and section 659. And at the bottom, we have different weights for these components. So we could just simply take, for example, the average of all of these. And this is using the average function. But that wouldn't be giving us the correct course grade because it's not following the weights listed down here. So what we could do is we could say equals C4. And since these are all out of 100, it makes it really easy to simply multiply them by the weight. So we're saying D4 multiplied by the weight down here, D16 plus up here, E4 times E16, the weight, plus F4 times F16, G4 times G16, plus the final exam, H4 times the weight, H16. So that correctly calculates the course grade. Basically, we're multiplying each assignment value, each quiz value, by the weights down here, and since they're out of 100, when we add them all together, that gives us the course grade, correctly calculated with weights. But when we try to pull this down, like this, we just get a bunch of zeros for the other students. So the question again is, what went wrong? So recalling what we talked about with cell references, try to pause the video and figure out why this didn't work. And I'll give you a little look at what the cell was up here and what it changed to down here. Once you think you have it figured out and how to fix it, you can play the video again. So in this case, like the other problems we've seen, it's another issue with referencing. So here we're referencing the correct cells, all the ones here, and the weights. But when we paste it down, all of these move down 1. And that's because we moved down 1 here, and it causes all of these cells to move down 1 because they're all relative. So what we can do to fix this, if we go back to the original one, we want to lock in all these values because they should never move. It should always be this value for column C. For assignment 1, it's always this 10% here. So we don't want to hard code in 10% because that means we couldn't change the cell value. Instead, we want to basically hard code where it is, and we do that with the absolute reference. So I'm going to use F4. And what F4 does, if you recall, is it basically automatically puts in those absolute reference $ signs for us, so we don't have to just type them in. So I do that on each one of these cells here, hit enter, and now we can pull it down, and we get the correct values. So it is important that we don't put them on the actual ones that are for the assignment value. And that's because when we go down to the next row, it has to update for that student. So we always want it to update for the student, but we want the weights to remain static, locked in there. So the next thing we want to do in the sheet is we have some statistics down here we want to do about the course grade. So we want to take the average for each assignment down here, and we want to take the average for the course grade. So there's a function in Excel called average, and it does exactly what you think. It takes a range or a list of cells, and it gives you the average value. So we select the range here, and we hit enter, and we get the average. So one thing we might want to do is, that's a lot of decimal points. We really don't need that many. So we can use that number formatting to drop them down like this and get it down to 2 decimal points. So we could type that in again by hand, average, and then select the range again, but we can also just pull it to the right, and Excel will figure it out for us by updating those cell references. So here the range refers to this column. Because we pulled it to the right one, it's going to update the columns but not the rows, so it's accurate to the next one, and so on. You notice here we had a blank row, and we're getting a div0 error. And that's because there's just no data here, so the average function is just returning an error. So we can just delete that one since there's no data in there. This is going to be the average for assignment 1, assignment 2, assignment 3, quiz 1, quiz 2, final exam, and the course overall grade. So one problem, as you'll notice in these cells, there's some zeros. And these are where we'll say our students didn't actually submit their assignment. We might not want to include that in the average, but first we want to just highlight who didn't submit an assignment. So what we're going to do is use something called conditional formatting. So we want to only format wherever there's a 0 as red text. We could do that manually, just go in and color each one red, but if the data changed, we'd have to manually go back and change each one. So Excel provides a way to actually do this conditional formatting for us. So we highlight the area we want to apply conditional formatting to. We click the conditional formatting button up here in our home ribbon. And there's some built-in mode for us that will usually do most of the things we want. So in this case, we want to highlight anything that's equal to a 0 as red. So we're going to select equal to. So it's asking us format that cells are equal to, in this case 0. And the default right here, light red fill with dark red text. And we can hit OK. If we wanted to change it, maybe we wanted green text, we could select different options here, or we could go to the custom format. So for example, maybe we want bold, we want red text, and we want to fill it in with, let's say, a light blue. And hit OK. And now basically any cell in that range that we selected and applied the formatting to will be colored this with that background if it's equal to 0. If we were to update this to like a 10, the formatting would go away, or if we updated something else to a 0, the conditional formatting goes back. But that still doesn't fix our average problem. We're still getting averages of assignments that weren't submitted in with assignments that were. So it might be more accurate if we only took the average of assignments that were actually submitted, the ones that aren't equal to 0. So there is another average function, and it is called average if. So a lot of these basic functions that we'll be using, like sum, count, and things like that, also have an if version. And they work similarly, where we select a range. But in addition to a range, we're also going to apply a criteria. And a criteria is basically a rule, and it's only going to take the average of cells that pass that rule. So rules are given, or criteria are given in strings. That means they have to be surrounded by quotes. So in this case, our criteria is that it's greater than 0. So we can use greater than and less than to denote that it has to be like greater than a number or less than a number. We can say less than equals to do less than equals than a number. So for example, we could say if it's greater than equals to 1 instead, that would be greater than equal than number. But in this case, we're just going to say greater than 0. We have to end the string in quotes. So whenever we're talking about strings in Excel, it means they always have to be surrounded by quotation marks in our actual formulas. When you enter them into the Excel sheet as text, you don't have to worry about that, just if it's a parameter to a function in Excel. So in this case, we're going to say we're going to take the average of this range, C4 to C14, and we're going to only take the average if the cell is greater than 0. We hit enter, and now this is our average only if it's greater than 0. And just like we did before, we can pull it to the right. Still not going to work for the blank one. And we can see that we have the original one is for the range C4 to C14. The second one is now updated D4, D14, it doesn't touch the string because this is a constant, it's not a cell reference. And it applies the same basic formula over and over again, but it's updating the referenced range. So once again, you can see that we're getting too many decimal points. So if we wanted to fix it, another way we could do that, other than using the number formatting here, would be to go Control-1, get into our Format Cells option, and then we can select that we want a number, and then we can change the number of decimal points. In this case, we'll go with 2. So it's just another way of doing the same thing in terms of formatting how many decimals are shown. So in this case, we want to show the median. That's sort of the number that's in the middle of the list of numbers. So we have a built-in median function. And you can see that as we were typing median, it was giving us a tip down here that says returns the median or the number in the middle of the set of given numbers. So Excel tries to help us out by explaining what these functions are as we're typing them. You can also see that it shows that it takes a list of numbers or a list of ranges. So this works sort of like the average and the sum. It's just going to take a range. It's going to give us the median number in. Let's pull that over. So those would be the median values for each one of those assignments. So for max, we want to find the greatest grade, who got the greatest score, or what their greatest score was. And we can just use the max function for that. Looks just like the other ones we've seen. It's going to return the largest number in that range. So same thing for minimum number. We use the min function. And we pull it over. So one thing you'll notice is that we're getting a lot of zeros. And that makes sense because there's a 0 in all of these, so that's going to be the lowest. But that's not really helpful to us. I mean, we know that students didn't submit. So maybe we want to get values for the lowest that was not 0. So once again, there is a similar function to get the minimum, but apply some criteria. And we'll take a look at that now. So unlike the other one, it's not min-if. There is no min-if function. There is a min-ifs function. So it's very similar in concept, but the parameters are slightly different. So in this case, we can see that it says we're going to start with a range. So the range are the ranges that we want to take the minimum of. Then we're going to have something called a criteria range. So we'll get into more of what the criteria range is, but for our case right now, it's just the same as the range we're taking the averages of. Our criteria is very simple. It is simply greater than 0 once again. So min-ifs is quite powerful, just like the ifs version of functions. So most functions have both an if version and an ifs version with an s on the end. And we'll take a look more at those ifs functions in a second. But this is basically how we got the minimum without counting zeros. We have two ranges, they're the same in this case, and we're saying greater than 0. So we're only going to take the minimums of ones that are greater than 0. Lastly, we want to get the number of submissions for each assignment or each quiz. So there's a function called count, and count basically counts the number of numbers in a certain range. So we did that, we'd get 11. We're saying count that range, and it's 11. It's not very useful though, because it's counting the zeros, because they are numbers. This would work if, for example, instead of zeros, we just had blank spaces. Then it would count 9. But since we actually have zeros entered, we're going to have to use a little more advanced function, and that would be the count if version. And that works just like average if. It takes the range and the criteria, which is greater than 0. And that gives us the count that are greater than 0. I highly recommend taking a look at the if and ifs functions in both the Excel tutorial slides that I posted and the Excel documentation online, because they are quite powerful tools, but they can be a little bit confusing to use at first. And we're going to take a little more advanced look at them now. So over here in this table, what we want to do is we want to count how many students have a letter grade of A, how many have a letter grade of B, how many have a letter grade of C, how many have a letter grade of D, F, and so on. And we're over here, we have a list of basically what defines that grade. So anything higher than 80 would be an A, anything higher than 70 would be a B, anything higher than 60 would be a C, and so on. So one clue here is we're going to be using a count function of some kind. Down here, we used count if, because we're simply applying a simple criteria to the range. So we could do that again for this first one, because we just want to count how many students got a final course grade greater than 80. So that's easy enough. Well, maybe not that easy. Hopefully you're paying attention there and just caught the error I made in that formula. Let's rewind it a little bit. So we can see the formula right up here. I'll just give it a bit of a highlight. We can also see it in the address bar here. So I'd like you to try pausing the video now, take a good look at that formula, and try to figure out where I went wrong. There's some small thing with that formula that's not quite right, which means I'm not going to get the right result. Okay, welcome back. So hopefully you figured out what's wrong with this formula. So when I was typing it, I was planning to write out equals count if, but it ended up with just count. There's a problem with that. The count function doesn't take a criteria. It only takes a set of ranges or a set of values and counts how many are in there. So the correct function I should have used is count if, and the formula should look something like this. Equals count if, the same range, JF or J4 and J14. That would be our range of course grades that you can see highlighted right now in blue. And the criteria is the same, greater than 80. The issue here was that I forgot that if, because count and count if are two different functions. Count if takes range and then you give it a criteria, and it'll only count the values matching that criteria. So let's take this off the screen, and let's play the video again and see what happens once I ran that function. So you can see the result I got here was an 11. But if we thought for a sec, or even a few seconds, about that result, we could see that it's likely wrong. The range we were selecting from was right here, the course grades. And we can see that there's only 11 entries in there. And out of those 11 entries, only 2 are above 80. So if I stopped for a second and just thought about it a bit, when I got the result of my formula, I could have quickly figured out that something was wrong. So when you're doing Excel, either in real life or in the assignments, make sure that you think about the results you're getting and make sure that they make sense. If you're only selecting from a list of 11 and it's saying that 11 are above the criteria and you can clearly see that's not the case, you should go back, take a look at the formula, and make sure the result you're getting makes sense. In this case, it shouldn't have been an 11, it should have been the value 2, the number 2, because there's 2 values for 80 that are above our criteria. That'd be the 82 and the 88. So let's continue on with this video, and hopefully I don't make any more blunders like that. So that's easy enough. But what happens when we have to do it between two different numbers? So now we want to count between between 70 and 80. So anyone that got between 70 and 80 would get a B. Can't really do that as easily with just the count function. So instead, we can use count ifs function. So this takes multiple criteria and multiple ranges. So the first criteria range is going to be the course grades. And the first criteria, we can say, is going to be greater than 70. So the second criteria range is just lets us keep adding more criteria and criteria ranges. So basically, the range has to satisfy, or the cell in that range has to satisfy that criteria to be counted in the count. And as we add more, it means there's more criteria that has to satisfy. So for it to be counted, it has to satisfy every criteria and every criteria range. So the criteria range is the same. We're still applying the criteria to the course grades. But now we can say we want it to be less than equal to 80. So we're saying that the first criteria being applied is the cell in this range has to be greater than 70. And the second criteria is it has to be less than equal to 80 to score that B. We do the exact same thing down here, and we could just type it out again. One problem is we can't just pull it down like this. There's two issues here. First one is the range is changing on us because we didn't make it absolute. But even if we made it absolute, let's do this. Using F4 again. Even if we made sure the range was correct by pulling it down, the problem is the criteria aren't going to change. So that's not a big deal. We could just type in here, we could change this to 60, we could change that to 70, that's fine. But maybe we had a really long list and we'd want to pull it down really far. We don't want to type that out each time. So one thing we could do is we could use that concatenate operator. So we saw that in part 1, I believe, but it's also in the Excel tutorial slides, and that is the %. And what that means is we're going to make a string by adding two strings together. So we're saying a greater than sign and some value. And that value is basically going to be over here. So it's going to be the value of this cell, M6. So we're saying we're going to make a criteria, and that criteria is going to be equal to the greater than sign and whatever the value of M6 is. We can't just say plus, because plus is a mathematical operator that works on numbers. In this case, we're working with strings. So when we're working with strings and we want to add something to text, we have to use the and %. And that's because we're going to make a text that says greater than the value here. So we also have to update this one. We're going to say concatenate with the value up one cell. So it's going to say it has to be less than equal to the value up there. And we can paste this down. And it will work correctly because those cell references aren't locked in, the M7 and the M6. So each time we go down, it's going to update the cells to drop down one. So the purple one's always going to be one above, and the red one's always going to be on the same line to get the correct counts. So the next thing we want to do is we have a few different sections in our data, 3 different ones, 1, 3, and 659. So what we want to do is we want averages for the certain section, we want a minimum for the certain section, we want a maximum for that section, and the overall the number that passed. So we can't simply just do a average if here, because that applies to a whole range. But we only want to count the ones that are for section 1. I mean, we could manually select just single the ones that are in 1. Problem is that is if we change section numbers, or if we added more students to the list, or things like that, then we'd have to change our ranges. So we want something where we can select the whole range or the whole table and have it automatically count them based on the section number. So in this case, we're going to use the more advanced average ifs function with the s on the end. And that's similar to what we saw with count, in that it takes multiple ranges and criteria to apply to that range. So for the first range, that's going to be the range that we're taking the average of. So we're always going to be taking the average of this range. And that makes sense. This is going to be the assignment 1 average. So I guess we actually want to take the course grade average. So we can move over here to course grade. So we're always going to be taking the average of the course grade. Now here's where it gets a little bit tricky. We have a criteria range. So in this case, the criteria range isn't the course grade because we don't actually care what the grade is. We care what their section is. Well, that's okay because we don't have to apply it to the same one. We're not actually applying the criteria to what the grade is. We're applying criteria to what the section is. The way this works is these two ranges have to be the same length, and they sort of have to line up with each other. So we know that the first element in this range is the section for this grade. And then we apply the criteria. So the first criteria is the criteria to that first criteria range. And in this case, we're going to say we want it equal to section 001. So we're saying in this range, the criteria range, it has to equal to section 001 for it to count in this average range over here. So if it equals section 001, Excel will look over, see that, and add it to our average. If it equals section 659, it'll look over and it won't add it to the average because it's not the correct section number. So that gives us the average for just section 001. So again, we can't pull this down, not just because we don't have absolute references yet, which we'll add now, but because that criteria won't change. It's sort of hard-coded to section 001. So we could do something like the concatenate that we saw before, where we go and the section number. But in this case, when we have a criteria, if we simply just set it equal to a value, it means that that has to be equal to that value. So when the criteria is a number, it means it has to be equal to that number. If we want it to be greater than or less than something, then it has to be a string with the greater than or less than. Since in this case it's just some text, we can simply just say equal section 001 or whatever's to the left of the cell. And that means it has to be equal to that section that's found in cell L12 to be counted in this average. The advantage of that is when we pull this down, it will now update. So we locked in all of these ranges so they don't change. The only cell that's changing when we pull it down is the one that doesn't have an absolute reference, and that's going to change what section we're looking at. So each time it's going to look at a different section number and just take the average for that section. So it's the same idea with min. Use min ifs. It works the same way. This is the range we're taking the minimum of. This is the range we're applying the criteria to. And this is the criteria, equaling section 1 in this case. We want to make sure that we have our absolute references, using F4 in this case. You can also type them in manually. And those gives us the minimum in those sections. And we could do the same thing here with max ifs. Again, takes the range we're applying the maximum to. Take the criteria range, the one we're applying the criteria to. In this case, the criteria is that it has to equal the section over here on the left, section 1 for the first one. And we'll lock those in. And pull it down. So in this case, we want to know how many students passed in each section. So this is a counting problem. So we're going to use count ifs again. In this case, the criteria range is going to be for the case of count ifs, the criteria range and the range that we're actually taking the count of are always the same. So in this case, we're going to look at this range and we want to know how many are passing grade. Oops. So passing grade is going to be equal to 50 or greater. So we say greater than or equal to 50. But we also want a second criteria. So in this case, the first one is that it has to be greater than or equal to 50, but we also want the section to be correct. Because if we just did greater than or equal to 50, that would just be how many passed in total. We want how many passed for a specific section. So we select the section numbers, and we're going to say that it has to equal the section over here. So the criteria is the actual section number, and the criteria range is the sections. And since we're going to be pasting this down, we have to make these absolute ranges. And we're going to leave the cell relative, so it will change. So the criteria changes as we paste it down. There we go. So that's all for this part. In part 4 of this tutorial, we're going to be taking a look at Excel's logic functions. So logic functions basically allow us to make some sort of choice based on the data. So you can see here in this sheet, we have our student data again. I've added a few new columns, and we also now have a failed or between 70 and 80 column. So in this failed column, we want to output the text pass or fail based on if the student passed or failed the course. So this isn't something we could simply do with average ifs or count ifs, because they're just going to return us a number, maybe the course's average or the student's average. They're not going to actually output the text pass or fail. So in this case, we need to make a decision based on if the student passed the course or if they failed the course. And to make decision type formulas, we need to use a function called if. It basically allows us to make a choice. So in this case, we want to output pass if it's greater than 50 or greater than or equal to 50, and fail otherwise. So we use if. we say that the logical test, so this is what we're actually, the criteria that we're applying. So in this case it is going to be the course grade, is it greater than or equal to 50? So notice in this case, it's not taking a string, it's taking a logical test. So this is going to be using our Boolean operators that I discuss in the Excel slides. So these would be things like less than, greater than, equals, not equals, things like that normally return true or false in Excel. In this case, if is going to take a true or false value, which is going to be returned by this operation. In our case here, we're saying, is the cell L4 greater than or equal to 50? That's either going to return true or false. In this specific case, since it's 64.1, it's going to return true. So the next parameters to the if function are a value if true and a value if false. So if this is true, if L4 is greater than or equal to 50, it's going to return this value in the second parameter. In this case, we want to output pass. So this is a string, and it's a parameter to a function, so it does have to be in quotes. And the last parameter is what we're going to output if it's false. So if L4 is not greater than or equal to 50, we're going to output fail. So we can drag this formula down because the only reference is to the cell right beside it. It doesn't affect these constants, 50 or the strings, and it's the same logic being applied. We're just changing which cell we're applying to it. So see down here, we're talking about L9. So we can make these if things a bit more complicated with two other functions called and or. By nesting them in the if function, we can make more complex choices. So in this case, we want to output yes if it's between 70 and 80, and we want to output no otherwise. So we start with an if statement like before, but in this case, the logical test is going to be a little more complicated because we're doing two things. We both want to check if it's greater than 70, and we want to check if it's below 80. To do that, we use the AND function. So we want to check if two things are true. So we're saying if the course grade is greater than 70 and the course grade is less than 80. So the parameters of the AND function state that all these logical tests have to be true for the AND function to return a true value. If any of these logical tests in the AND function's parameters are false, AND is going to return false. They all have to be true for AND to return true. And that's being returned to the if function, which then is going to get the true or false, and then it's going to return the parameter value if it's true, and it's going to return the parameter value if false, if it's false. So if it's true, that means the value is greater than 70 and less than 80. We want to output yes. If it's false, that means it's not in that range. We want to output no. And we can drag it down again. And we get the results that we expected. Again, these have to be in quotes because they are strings. If we wanted to return a number instead, so for example, if we wanted to return the number 9, if it wasn't in that range, we could do that, and it wouldn't be in quotes. So the next case is going to be a little more complicated. So you notice now in these grades, we do have a participation component. So in this case, we want to base this participation component on if they have 5 or more form posts. So we could do that. So the participation grade is going to be out of 100, just like all the other grades. And we want to give them the full 100 mark if they have greater than 5 form posts. Otherwise, they get 0. So we say if the logic test is going to be on the number of form posts, and it's going to be greater than or equal to 5. And if it is, we want to give them 100. Otherwise, we want to give them a 0. We can paste that down. You can see that it's working. So they had 6, so they get 100. They had 9, they get 100. Well, people that got 4 got 0. And this is already set up to do the correct calculations for the overall course grade. So this one was pretty easy, but what if we wanted to make that a little more complex? Basically on maybe their MyLab homework. So in this case, we want to check if their participation mark, to make their participation mark, we're going to base it on having 5 or more forum posts or having a grade of 70% or higher in the MyLabs. So if they have 5 or more forum posts, they get 100. If they have more than 70% in the MyLab homework, they get 100. Otherwise, if they don't meet either of those, they get 0. If they meet both, they can still get 100. If they have more than 5, that's fine. If they have more than 70%, that's fine. But they have to have one or the other to get 100. Otherwise, they get a 0. So you should pause the video now and try to figure out how that if statement is going to work. So try to write the if formula. I'll move this over here. And then once you unpause the video, we're going to take a look and see if it's correct. So in this case, just like we saw before where we used an AND function in our if statement, we're going to be needing to use an OR function. So it's if, and our logical test is going to be an OR, because there's 2 different conditions that can make it true. So the OR function's like the AND function, except if any of the logical tests as one of its parameters are true, it returns a true. So if it had like false, 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 and a true, it would still be true, unlike the AND function where they all have to be true. So in this case, we have 2 tests. First one is we want to check that the forum posts are greater than or equal to 5, or if the homework is greater than 70%. Or higher. So what this is saying is we're going to return true if G4 is greater than 5, if they have more than 5 forum posts, or if H4 is greater than 70, if they have greater than 70%. If either of those are true, we're going to send a true to the logic test in the if function. And if the logic test in the if function returns true, we return this value, which in this case will be 100%. Otherwise, we're going to return nothing. And we can paste that downwards. And we can see that in most of these cases, it seems to have worked fine. So this person got 0 and 0, so they get a 0 because they didn't meet either obligation. This person had 0 forum posts and they only had 56, so they didn't trigger either of those conditions. Well, for example, here they didn't have any MyLab homework, but they did have the 5 or more. So it does seem to be working correctly. So you should make sure you understand how this is working. So we have a nested function in this case. So if you're not sure how you nest functions, do look at that tutorial slide. It does discuss nesting functions, but the idea is Excel is evaluating the innermost function first, this OR. So it's checking if this condition is true or this condition is true. If either of them are true, then this is sort of being replaced by the value true or false. And then that value is being sent as a parameter to the logic test in the if function. And then the if function simply makes an evaluation based on whether it's getting a true or a false. So it can help to take a look at what this might look like if we just did the OR function without the if. So actually I'll copy it exactly. I don't want to change the reference. So if we were just doing OR, we would get a Boolean result. So a Boolean result is going to be either a true or a false. So this is what we get just if we run that OR function. So in this case, we get false because they don't have enough forum posts. They don't have enough MyLab homework, so they get a false return. In this case, they have both, they have the MyLab homework, but not the forum posts, so they get a true, as long as they have one or the other. And this would be the value that's being sent to the if function. So we could also write this if function by just basing it on the value that's being returned by the OR function in this cell, instead of combining it in one. So this would be the exact same thing, except we're referencing the cell beside it, so we're sort of like splitting up the function into 2 cells, instead of having it all in one cell like we do over here. So the OR is returning true or false, and then the if's making a decision based on that true or false value. So this one can be a bit tricky, so I do recommend reviewing those tutorial slides that talk about the if function, as well as the Excel documentation on if functions. So for the next case, we want to make this a little bit more complicated. So instead of simply returning a 100% or 0%, we want to have a few different categories down here. And for this one, we're just going to be basing it on the form posts again, but we could make this as complex as we want by chaining multiple if statements together. So in this case, we want to check if it's 100% or more, we give them 100% or more participation mark if they have 5 or more form posts, 75% for 3 to 4 form posts, 50% for 1 to 2 form posts, and 0 for 0 form posts. So the way we can do this is we're going to nest if statements inside of if statements. If you know anything about programming, this would be equivalent to a nested if statement in programming. So the first if statement we're going to do, we're going to check to see if it's 5 or more. So the logical test on the form post is going to be greater than or equal to 5. And if that's true, we want to return 100%. But now, if that's not true, we don't want to just return 0. We want to do another check. We have to do this check down here. So to do another check, we need another if function. And now the logical test is going to be checking if it's 3 to 4. So we could just say, use an and like do the, is it greater than equal to 3, is it less than equal to 4? But if we got to this position, or got to this point, we know that this is already false, or this has to be false for us to get to this if function. So we know it's already not greater than or equal to 5. So we only really need to check this lower bound. So we could say it is greater than or equal to 3, because we know it can't be 5 or higher, or the first one would be triggered and we'd already returned 100. If this is true, we want to return a 75%. So now, if this is false, we want to go down to the next one, because we can't just return 0 yet. We have to do the next check, which is if it's 1 or 2 form posts. So again, we're going to start another if function. And the logical test here is going to be on the form posts again. And we're going to be asking now if it's greater than or equal to 1. So again, we don't have to use an and to check both, because if we are at this point, we know that this is gone false. So it's not greater than or equal to 5, because we're triggering this if statement. And we know that this is going to be less than 3, because this was false, and we're triggering this if statement. We know that's the case, because if it was greater than or equal to 5, we would have already returned 100. If it was greater than or equal to 3, we would have already returned 75. So we can only get this depth if it is equal to 2 or less. So we're just going to check if it's greater than or equal to 1, and then we're going to return a 50. So we could start another if statement and then check if it's 0 or not, but we don't need to, because we know if it's not equal to 1 or more, then it has to be equal to 0 or less. And since you can't have a negative form post, we can simply say 0 here. So saying we're going to return 0 if all this other stuff was false. And now, an important thing here is to make sure we close all these functions. So each time we open a function with a bracket, we have to make sure that we're ending it somewhere. So drag this down, and we get the new participation marks that actually have multiple values. It's not just simply 100 or 0. It's now 75, 50, 0, or 100 based on these rules. So this function does look a bit intimidating, so let's take a closer look at it. There, I made it a bit bigger, and we'll bring it up here. The first part here is checking if G4 is greater than or equal to 5. That's the number of form posts. If it is, then we are going to return 100. So if this is true, we're getting 100. If it's not true, if this is false, then we're going to try this. So these are the parameters for the first if function, the logical test, 100, and then these other nested if functions. So if this is false, we're now going to try returning this value. So this value is sort of similar. It's saying if G4 is greater than or equal to 3, we're going to return 75. If it's not greater than or equal to 3, then we're going to return what's in this parameter over here. And in this case, that's going to be the result of this if function. And this if function says if G4 is greater than or equal to 1, return 50. otherwise return 0. So the way to read this is we're starting at the left, checking this first equation, and we know that if this is true, we return the first value. If it's false, we return the second value. So all of this in this yellow box is the third parameter of this if function, this first outside if function. Then we go in a layer deeper, everything in this yellow box, and then we're checking if this logical test is true, then we just return 75. If not, then we have to return the result of what's in this black box here. And the same thing, in the black box, we're saying if G4 is greater than 1, then we are going to return the second parameter here, 50. Otherwise, we return 0. And since these are just constants, we just return 50 or 0 at this point. So it can help to sort of break it out like this. And these brackets here do give you a good idea of where these functions start. So each time you see a bracket starting, it means we're going in another level deeper in the nested function. So it is important to understand these because we will be using some of these on the assignment. And that brings us to part 5. In part 5 of this tutorial, we're going to be taking a look at Excel's lookup functions, namely VLOOKUP and index and match. So once again, we have this student grade example, a bit simplified now. We removed a few columns. And what we want to do is sort of answer a few of these questions we have down here by looking up things in the data. So the first one is, what is Joe Blogg's section number? I mean, we could just type this in S001, but that's not very useful. If we change something up here, it's not going to change down here. We could also just do a cell reference, like saying equals B4, and that works, but what if we moved this row down here? It's no longer B4, or we changed the data around a bit. It wouldn't give us the correct result. So we want to do something that's a little bit smarter. And we do that with the VLOOKUP function. So for full details, you should look at the Excel tutorial slides on OWL, but you can take a look at what Excel says about VLOOKUP. So it says, looks for a value in the leftmost column of the table, and then returns the value in the same row from a column you specify. So what this is going to do is going to look for a value in the leftmost row of the range we specify, and then pull a different value from a specified column. So if we select this table here, I'll highlight that. So if we select this table here, it's going to look in this first column. It always looks in the first column for the value, and then it'll, once it finds it, if it finds it, it's going to pull a value from a specified column. So if we say specify column 2, we'll pull it from this column. If we say column 3, it's going to pull it from that column. So the first value it takes, the first parameter, is the lookup value. So this is the value that we're actually looking for in the data. In this case, we're looking for Joe Blogg's name. Since this is a string, it does need the double quotes on either side. Next is the table array. So this is the table of data we're looking for that value in. Okay, so it's this big table here. Next is the column index number. So this is the column number where we're trying to pull the data from once we find it. So in this case, we're looking for the section number, and that is in the second column. So we put a 2 here. So we don't say the letter B. Instead, this function, we give a number, counting from the left. So this starts as 1, this would be 2, this would be 3, and so on. So we have to give a column index number. So when it says index number, that means it wants a number, not the column letter. Now the last one is pretty important. It's going to be a true or false value, and they mean different things. If it's true, it means we have to have an exact match. If it's false, we have to have if it's false, it's an exact match. If it's true, it's an approximate match. So we can try it with true and see what happens. So we got section 3, so something has gone somewhat wrong there. So what's happening is it hit a partial match on one of these names here, probably this one here, and didn't return the one that we want, which is Joe Blogs. So it's the first one that had a partial match, probably the J at the beginning. So what we really want is a full match. So we want to change this to false. So we only want to match with names that are exactly Joe Blogs, not ones that sort of partially match it or approximately match it. So in this case, it is pulling it from section 1. So if we were to do something like rename this to just Alice, you could see that we get an error because it's saying that there is no Joe Blogs in the data. But if then we were to add Joe Blogs back here, we would be getting the correct new value, section 659. So this is how we can basically look up that data smarter than just giving a cell reference. So the next question we get is we want Paris's final exam grade. So we can do the same thing with VLOOKUP. The lookup value in this case is their name. The table is the same. But here the column index number is changed. So I want you to pause the video and try to figure out what is the index number. So if this is the table, what is the index number of the final grade, or the final exam grade? So what is the index number of their final exam? So what value goes right here? So pause the video, and once you think you have an answer, unpause it and we'll take a look. So in this case, final exam is in column H, so the answer isn't H. Instead, it has to be an index number. So if we started counting here, this is 1, this would be 2, this would be 3, 4, 5, 6, 7, 8. So the answer is 8. The index number in this case is 8 because it's the 8th column in the table. So it's important to note that if this table didn't start in column A, for example, it started over here in column B, then it would still be number 8 because everything would be shifted over. So this isn't related to the actual column in Excel, it's related to the number of columns since the beginning of the table. And we'll take a closer look at that in a sec. Once again, we want this to be false, so it's an exact match. We're getting a result of 36, which is their final exam score right here. So we'll take a look at what happens if we were to move this whole table over a bit. So let's move it to column C. So you see our references are still fine. That's because Excel updated the table for us. So in some cases, it's smart enough to update your references when you move the data. But you'll see that the index numbers are still the same. That's because it's not talking about the 8th column. It's talking about the 8th column since the start of the table. So this would always be 1 wherever the table starts. This is always 2, 3, 4, 5, 6, 7, 8. So it doesn't matter where the table is. It's how offset it is from the beginning of the table. It's not the number of columns in the overall sheet. Let's move that back. So now we want to do something a little different. We want to find the student with the course grade of 59.1. So we might try VLOOKUP, but we're going to run into a problem pretty fast. So the lookup value in this case is 59.1, and the table array is here. The column index would be 10. And true. But we have a problem. So the problem is VLOOKUP, as by its definition, always looks for the value, the lookup value, in the first column of the table. And what we're trying to do is look up the value over here and then return the name of the student. So it's sort of the wrong way around for VLOOKUP. So we're going to have to try a different approach. So there are some other functions we can use that are a bit more powerful, but a little more complicated to use. And the first one we can try is match. So this returns the relative position of an item in an array, which is a bit complicated, but we'll take a look at what it actually does. So we can type in what we're looking for, 59.1. So a lookup array, instead of a whole table, it's just a two-dimensional area that we're going to be searching for. So in this case, we're searching in the course grades for that course grade. And just like with VLOOKUP, we have a match type, and we're going to want that to be an exact match. In this case, it's a 0 for exact match. So what match is returning is a number. And what this number is the count from the start of the array. So it's saying that it's the 11th entry from the start of the array, which is a little bit useful, but still not the student's name. So to get that into a student's name, we have to combine it with a second function called index. So index is sort of the reverse of match. Index takes an array. In this case, that's a range. So in this case, we'll have the range of students. And then it takes a row number. And that's useful because what we just returned was a row number of where that course grade is relative to that range. So this isn't a row number for the overall Excel sheet, it's relative to the array we gave it. So row number 1 for this array or for this range would start here. Joe Blogs would be in number 1. Number 2 would be this guy. Number 3 would be that, and so on, all the way to the end. So we can use that value returned from match in our index function to say we're going to return the 11th name in this range. And we just have to give it the 2 values, and that gives us the name of the student. So match is looking up the row number relative to this range, and index is looking up the actual value relative to this range. So it's important that the ranges are the same size and in the same order. So example, this has to be Joe Blogs grade. They can't be in a different order. So it's kind of a pain to have using 2 cells to pull that in. So we can combine this into a single cell by using nested functions. So we'll do that as an example here. And this one's going to be a little bit more complicated because we want the student with the largest grade. So we could do that by over here saying, well, what is the largest grade? And take a look. So now we know the largest grade is 88. So what we're going to do is we first do index. So actually, let's start with match. Do match. The lookup value is what we returned, the largest grade. The lookup array is where we're looking for it. The match type says how we're going to look. In this case, we want an exact match. Right now, we're just getting a return value of the row number, but we want to try to combine this into one function. So we have to wrap that match in an index. The array where we're looking for the name is over here. The row number is what match is returning. So match is going to be called. It's going to find that, and it's going to return it as the row number to index. So we get the name. So what's happening there, match is looking in this cell for what the maximum is, which this returns. And then it's going to look in this range. It's going to try to find that. If it finds it, it's going to return the row number relative to the range. And it's going to return that right into the index function as the second parameter. Now the index function looks in this range here that we gave it as the first parameter and returns that value. So if it returned like number 5, it returned the 5th one in that range. So now we're still using 2 cells because the question was a bit more complicated. We had to use a max. We can still combine this down into a single cell by nesting all these functions together. So in this case, we want to return the student with the lowest grade. So we can start with min. We know we want to figure out what the minimum grade is. So it's 37.4. So now we wrap that min in the match because it's going to be the lookup value. That's the minimum grade of the value we're looking for. We take a look at the lookup array over here. This is where we're looking for it in. We want the match type to be 0, an exact match. So now we're getting the row number, so it's the 10th one in here. Now to actually retrieve the name, we have to use the index function. First parameter is the array. And all this is basically returning us what number it is in that array. So we've basically nested each one of those calls inside. So it's starting with max to find the maximum number, and it's using match to find where that number is in that array. So it's going to return like it's the 5th grade in that array. And then we use index to figure out in this range over here, what is the 5th name. So we can combine that all together, and even though it's a bit complicated, it's extremely powerful because it can look both left, right, up, down. So we can do much more versatile searches than we can with VLOOKUP or HLOOKUP individually. So there also is HLOOKUP, like I mentioned. It's the same idea as VLOOKUP, it's just that we're going in the other direction, and the slides do cover that. Part 6 of this tutorial, we're going to take a look at a few functions we haven't covered yet, including some rounding functions, some financial functions, and some basic mathematical functions. In this sheet, we're going to try to calculate a car loan. We're going to try to calculate the monthly payment and the total amount the loan is worth. So we have a few values here. We have the principal, how much the car is worth. We have the down payment we're going to make, that's the amount we're paying up front. We're going to have a trade-in value, how much the old car we're trading in is worth, so this is going to be credited towards the loan. We have the annual interest rate, and we have the number of years this loan is going to be for. So we could write out this formula ourselves to do this calculation, but Excel has a built-in function called PMT, which calculates the payment for a loan based on a few constants. So the first thing it's going to take is the rate. But this isn't the annual rate, it is the monthly rate, or the rate per payment. So we have to divide the annual rate by 12 to get the monthly rate. The second value it takes is the number of payments. So in this case, we're going to assume that there's going to be monthly payments, month of months. So that means over 5 years, there's going to be 12 payments a year. So 5 times 12, or in our case, since we want this to be variable, if we want to change these numbers, it's going to be B7 times 12, since that's the length. The last value, PV, is the present value. So that's going to be equal to the amount the car is worth, minus the down payment, and minus our trade-in value, since that all goes towards the cost of the car to begin with. So this gives us a value that says the monthly payment is going to be $379.11. And it's important to note that the payment function is always going to return these as negative values. So if we wanted to display this as a positive value, we could simply times the value by -1. Or we could use another function called ABS for absolute value. We could wrap payment in that. And ABS basically just takes whatever value it is and makes sure that it doesn't have a sign on it, a negative sign. So if it's -1, it's 1. If it's 1, it's still 1. But for now, we're just going to leave it as the negative number. So the other thing we want to calculate is the total value of the loan. So basically how much it's going to be with the principal plus the interest. So we can do that with a function called present value, or PV for short. So the first thing it's going to take is that rate again, and once again we have to divide it by 12 to get the monthly rate. And it's going to take the number of payments, which is going to be the years times 12. And the last value it's going to take is the monthly payment, which we just calculated here. And it's going to take that as a negative value. And that is the total amount of the loan. So that would be the principal plus the interest. So the next functions we're going to take a look at are rounding functions. So you might think, why do I need rounding functions? I already have these nice functions up, or display options up here to basically round the values for me. So the problem is, if we were to do that, I can round these values all the way down, so it's just one number showing. And we were to take the sum of those numbers, we're getting a result that doesn't seem to make sense. I mean, 1 plus 1 plus 2 should be 4, not 4.65. What's happening here is this number formatting, like using these to change the decimal places, is only changing how the number is displayed. It's not changing how the number is actually stored in Excel. So even if it's only showing 2 decimal places, Excel's still using all the decimal places available to calculate any equations you do on it. So if you do the sum, it's using all the decimal places, all the precision it has. It's not rounding them up just because it shows it rounded up. So to actually round up the number, so Excel actually uses it as a roundup number, we have to use a function called round. And it works pretty simply. The first argument is the number we're rounding, and the second number is how many digits we're rounding it to. So if we gave it a 1, that means it would be rounding it up to 1 decimal place, so we'd have like 0.5. If we gave it a 0, it means it's only going to round it up to a whole number. So in that case, we'd get 1. Drag it over, so it's going to calculate the rounding up to a whole number for each value. And the way it does rounding is based on if it's 5 or greater, it goes up, and if it's below that, it goes down. If we do the sum now, since this isn't just a change to how the number is displayed, it's a change to the actual value, we'll get the result that we're expecting of 4 here. So there are a few different rounding functions if we want to have different rules. For example, if we always wanted to round up, we could use the round up function. This works the same way. It takes the number and the number of digits, 0 for the whole number, except this one will always round up. So if it's anything above 0.0, like 0.01, it's going to round up to the next whole number. It's sort of like the ceiling mathematical function. We also have a round down function, which does probably what you're guessing already, which is it does the same thing, but it's going to round it down to the next whole number. So 0.51 becomes 0, 1.45 becomes 1, and so on. So it's the same as the floor mathematical function. So the last functions we're going to look at are some extra math functions. So we have a few numbers up here. We already talked about the ABS function, or the absolute value. And that's basically going to give us the value without the sign. So if it's a positive number, it's just going to return the same number. If it's a negative number, we return that without the negative sign, or times -1. So we get the same values unless it's negative, and it just returns the absolute one. Same as the absolute function in math. We have the square root function, which does the exact same thing as the square root function in math. Just takes the number to take the square root of. You'll notice that we're getting errors. That's because you can't take the square root of a negative number. So we do get errors if we try to do something that's not possible. And we have a power function. So it takes a number and the power you want to raise it to. So it should be noted that the power function is actually the same as the power operator. So if you recall, we can also use this caret symbol, the shift 6, to do the exact same thing without a function, using an operator instead. So the power function is the same as the operator function. It's just a different way of doing the same thing. We also have a few other functions we can apply to a range of numbers. We've seen some of these before. Familiar with average. We're going to take the average, some numbers. We have standard deviation. So there's two different kinds of standard deviation. There's .p and .s. One takes the standard deviation of a whole population, and the other one takes the standard deviation of a sample. There's slight differences if you get into the statistics of it. So in this case, we're going to take a whole population. There's median, which we saw before. Returns the number in the middle. We have mode, which returns the most frequently occurring number. And they pretty much do what you expect. In most cases, if there's a mathematical function, there's probably an Excel equivalent. If there's a statistical function, there's probably an Excel equivalent. So we also have a few functions for dealing with dates. So we have a start date here, and we have an end date here. So what we might want to do is figure out what the year of this date is. So it seems obvious when you look at it, 2020, but if you want to actually extract that dynamically, it gets a bit more tricky. But we have a function for that. So the year function, if you give it some sort of date, it returns the year number. The date function does the same thing. If you give it a date, it's going to give you the day number. These can be useful if you have to break down a date into its components for some reason. Month function takes date and gives you the month number. Pretty much what you'd expect. Now, if we wanted to calculate the days between these two dates, there's two different ways we could do that. There's the days function. So that takes an end date and takes a start date, and it gives us the days between. And the other function, which is a little more powerful, is called dateDif, and that takes a start date and then an end date, the opposite way around. Then it takes a string that lets it know what you're trying to find the between of, but what unit it should be in. If it's a D, it's days. If it's an M, it's months. If it's a Y, it's years. So in this case, we'd say D, and it'll give us the same result, the number of dates. This is useful because when we get to months, there is no months function in Excel to tell us the number of months between two dates. So we have to use that dateDif. We do the start, do the end. In this case, we're going to say M because we want the unit to be months. So we can do the same thing down here. dateDif, start, end, and we're going to get it in years this time. So that's how we get basically the differences between two dates. Problem is, if we try to just do this with math, we're going to be getting it in days. So that is a third way. We could do it in days, but it wouldn't give us the number in months or years. So that's 3 different ways. We can do it for days and only one for months and years, unless you want to type out a very complicated formula that would have to account for things like leap years. Congratulations, you've made it through the Excel tutorial. So where do we go from here? Well, if you feel like you still need a little bit more Excel knowledge or brushing up on your Excel skills, your next stop should be the MyLab homework. On MyLab, you can find a number of sort of homeworky type assignments. They're not graded in terms of being part of your course grade, but MyLab does have an auto grader that will give you some feedback on those. So if you feel like you need to brush up a bit more, try some of those Excel problems on MyLab. That's all I have for you in this video. Thank you for watching and have a great day.